Hello all, this video is about how to program high-speed counter inputs in a Mitsubishi FX5U CPU. Hello and welcome back, this is Gerd Zeller from Zeller Press Control Systems and off we go. First of all, we're going to create a new program selecting the FX5U series, and while this is open I'm just going to mention that this video is made because I had a request from a community member of my YouTube channel, and I'm gonna link some other videos that I already made about this subject in the description below. Alright, the program is open, and now we will find on the left side in the navigation window the item parameter FX5U CPU, and then we will have to go to the module parameters, and then we will have to go to the high-speed I/O. Alright, and here we will find the high-speed counter detail setting in the middle of the screen, and just make a double click on the detailed settings and another screen will open, and here you can actually see the parameters for channel 1, and this goes all the way through to channel 8. And like I said, I already made a video about the inputs, which I will link down below. Alright, so first of all we will have to see if we use the channels at all. I'm gonna just make 3 channels right now and also make the program code for it, and I think I will give you a link also where you can download this later on, so maybe this is gonna help you also. Alright, now I go back and forth here. Okay, here we go. Use. Alright, now we have the usage of channel 1, channel 2, and channel 3, and that's already it for this setting. If you want to see where the hardware is wired to, there is a button down below here on the right side. If you push this, you can see which, oh sorry, I forgot something. I have a 2-phase 1 multiple encoder that I have wired to 3 input channels, because I have only 1 encoder left right now, so I need to also check this on here, and this is also explained in another video, the 1-phase and the 2-phase multiple. And now we can go to the occupied input explanation, and here you can see which input refers to which counter channel. I'm trying to make this a little bit bigger, and if you look at it, I have a 2-phase count, which you can see on the left side here, 2-phase counts, and then you can see the 2 phases are wired to the input 0 and 1, and from the channel 2 they're wired to 2 and 3, and also the channel 3 is wired to the inputs X4 and X5. And the P and the E is external enable and an external preset, which I have also explained in another video. Alright, so this is it for right here. And what happens if you use a counter, you got very fast signal switching, so therefore you need to set the input response time also. Okay, then let's just check this on here if this is okay. There is no error. And then we push OK, and then the next thing will be also on the navigation window on the left side here, the input response time, which we need to set to the lowest possible time, which I normally make 10 microseconds. And I will also change this at the end of the video. Then you can see what happens if this time is set too high, because then the encoder will not be read, or respectively the input will not be recognized by the PLC. Okay, so we got channel 1 with 0, 2, 2, 3 for the channel 2, and the 4, 5 for the channel 3. Let's see if this is all okay here. Okay, there we go. And also check this again. And if there are no errors, fine. Do not forget to apply, because if you don't apply, it will be erased and you have to do it all over again. Okay, so that's it for the parameters. And next is we have to make a small program code, and therefore I'm trying to explain you the function, which is actually an HIOEN function. And on this HIOEN function, I'm going to move this a little bit over here. On the HIOEN function, you got actually 3 parameters. And this is explained a little bit further down here, where it says the S1, that is actually telling you, or that is actually describing the function of what the high-speed counter is supposed to do in the PLC. So if you use the K0, it's just an ordinary high-speed counter. The K10 is a rotation pulse density measurement, which I have also made a video about. That I get a link, or you can see it up on the link in the video. Then a comparison table. This is pretty much like a cam switch box. And a pulse width measurement. This is also for some speed. And like I said, I'm only gonna do the K0 for the high speed counter, and the S2 is used to actually start the counter, and this you can see right here. The following table shows the values which can be specified in S2 and 3 for each function number. The counting, start and stop of a high-speed counter can be controlled for each channel of high-speed counter. And here you can see the channel 1 uses the bit 0, the channel 2 uses the bit 1, and so on. And if you make this in a decimal, you got like the value 1 for the channel 0, or for the channel 1 you got the value 2, for the channel 2 you got the value 4. So this is binary, and if you want to look up how the binary works, this is very easy to find in some internet thing. I can probably open this for you. Let's see here, binary to decimal. There you go. And there is a converter right here. And then you can just, okay, whatever that is now. You can just go ahead, and if you 1, 2, 3, 4, 5, 6, 7, 8. So this should be the value 1. And if you got the second bit set, then you get the value 2 in decimal, and so on. I think we should all know this. If you go to the bit number 3, you will get the value 4 and so on and so on. Yeah, so if you set the bit 1 and 3, you get the value 5 and so on. Okay, so let's make a new, respectively, we can just put it in this program body right here. Which is insert view rows. There we go, and then put an M1 in there, and then use the HIOEN function with using the K0 for the high-speed counter, the K1 for starting the channel 1, and K0 for stopping no channel. This is just later on the next one. All right, there we go. So this is your counter channel 1, and then we make the M2 HIOEN K0 channel 2 and stop channel 0, which is you write nothing to anywhere. And then the next one, I'm just gonna copy paste, use the M3 and use the K4 on the start channel, which is the channel number 3, what we just learned from binary to decimal, and also copy this 2 times and make an M4 to stop the channel. Okay, here we make the 0 and we stop the channel 1, and then we make an M5 to stop the channel 2. Misspelling. All right, and we make the M6 to stop the channel 3. So bit number 3, binary to decimal, is the K4, and there we go. All right, so now we can go ahead and just compile it or rebuild it. And download the program. Select all, download. CPU will stop, yes to all. Okay, here we go. So it said we have to reset the CPU. I think I made also a video about this. You take the reset button on the left side of the CPU, push it down until the arrow flashes, and then put it to run, and then we should be able to find the value, and the value can be found in a special register which I have anywhere. Okay, here it comes, one moment. This is all the explanation that I made in a previous video already. And special register list, there it is. All right, here it is. Sorry for the delay. Here you can see the special register. So for the channel 1, you can see it is the SD 4500, which I will just copy in the watch table. And I'm gonna make this also with the channel 2, and I think it always rises by the count of 30. So this is SD 4530, and the next will be the SD 4560. There we go. All right, and if we watch this with a left click, you can select Start Watching. And if I now turn the encoder, there will be no change because of the function is not started. So we have an M1, M2, M3 for the start, and we have an M4, M5, oops, so wrong spelling, M6 for the stop. All right, so now there are just some values because I did some checks before, so that's why we still have some values in there. And if I now switch the M1 to high, we will see also, let's just watch this up here. So if I turn the encoder now, we should hopefully see the SD for not turning. So what did I do wrong? There is an error. Diagnostics, module diagnostics, channel specified using communication for high speed does not have the appropriate parameter. Okay, so anywhere I made a mistake. So let's see. High speed I/O. High speed counter. There's no detailed settings. I think I forgot something. Use two-phase 1 multiple channel 2. Use two-phase 1 multiple channel 3. Use also two-phase multiple. Check. Okay. Yes, I did not push the apply button. Like I said before, you should push the apply. So right here it comes. And now download it again. Okay, now it says here, please reset the CPU module wants to run. Okay, that's what I'm gonna do. All right, now it's running, and now we will see watching is still working. So let's put this to high, and hopefully it's working now. There we go. All right, so now we can see the M1 is on, and our counter 1 actually started counting. All right, so let's do this with the counter number 2 and the counter number 3, channel number 3, and then we should see all 3 of them working. There we go. The thing is, if they're switched on once, they will always be working until they're actually switched off. That's what you can see right now. If I put them all to 0, the counters are still working until I actually stop them. So let's stop the counter number 1. And then you can see only the counter number 2 and 3 is still counting, and do the same thing with the counter number 2, then only the counter 3 works, and of course the same with the number 3, and then none of the counter works anymore. So this is how basically the whole program is working. And now, as promised, I will show you what happens if the inputs are not set to the according to the needed response time, because then you will find out that some of the values will be counting wrong. And it is really important to do that. So now we have them counting again. You can see all 3 of them are counting, and now we set the input response time. We take the channel 2 and set the input response time to the default, to the 10 milliseconds, and then you will see 10 milliseconds, and of course check and apply, and also go ahead and download it again, whole thing. All right, here we go. And it's still asking me to reset it again and put it to run and see if the monitor mode is still on. Yes. So if I now turn the encoder, wait, I have to switch on the channels accordingly. And number 3. So now you can see the number 2 only counts sometimes. If I move the encoder very slow, you can see it also counts, but this is like very slow. I got 360 steps for 1 revolution, so I turn it really slow, it's counting. And if I turn it a little faster, you can see it on those numbers right here, it does not count properly anymore. So this is why it is important to set the input response time accordingly. All right, and like I said, you will find this program in a download where I also give you the link to it. I hope it's gonna work in the comments in the description at YouTube. And then I thank you for watching, and that was it for the multiple high-speed I/O using a Melsec FX5U from Mitsubishi. Thank you and bye-bye.